Today I want to talk about some common sets. We have several common sets. We're going to use them during the semester. The first is the set of integers. The set of integers consists of the numbers ellipses -3, -2, -1, 0, 1, 2, 3 ellipses. So it keeps on going. Another way to say it is 0 plus or minus 1 plus or minus 2 plus or minus 3 plus or minus 4, etc. That's the set of integers. The set of natural numbers are the set of all positive integers, so they start with 1. So you go 1, 2, 3, 4, keep going. The set of whole numbers begins with 0 and then includes the natural numbers. So 0, 1, 2, 3, 4, 5, etc. The way to remember it is the set of whole numbers include the whole, 0. Get it? The set of rational numbers are the set of numbers that can be written as a divided by b, where a and b are integers, and of course b is not allowed to be 0. Those are numbers like plus or like 1/2, 2/3, minus 5/6, 12/4. Those are all integers. If you could write it as a ratio, that's where rational comes from, of two integers, then it's a rational number. Okay, what's a set of real numbers? Well, that's any number that has a decimal representation. They include both rational and irrational numbers. So every rational number is a real number, but some real numbers that are not rational are like pi, e, the square root of 3, or the square root of 5. Then we've got the set of complex numbers. Now, complex numbers are any numbers that can be written in the form a plus bi, where a and b are required to be real numbers, and I is that funky little thing such that when you square it, you get -1. So sometimes we think about I as the square root of -1. So there you have it. There are some common sets. Now, in algebra, we start out with numbers, but quickly we define something else, functions. Now, functions in algebra are not numbers, but they become numbers when you supply a value for the variable, or variables. We might have more than one. Okay, so in symbolic logic, the same sort of thing goes. A propositional function is not a proposition, but becomes a proposition when a value is supplied from the domain of discourse, which I call the DoD. Not the Department of Defense, the domain of discourse. All right, so and anytime I give you a propositional function, I have to give you the domain of discourse. I have to tell you what values you can plug in. All right, so let's look at some examples of propositional functions. So here's a propositional function, p of x. It's the statement x is even. And my domain of discourse is, in this case, I pick it to be the set of integers. All right, so what's p of 1? P of 1 is the statement 1 is even. Is that true or false? The answer is false. P of -4 is a statement -4 is even. Is that true or false? The answer is true. Why? Because -4 can be divided by 2 and get an integer. Anything that can be divided by 2 and the result is an integer is called an even number. How about p of 0? That's a statement 0 is an even number. Is that true or false? Well, actually it's true because 0 divided by 2 is an integer. 0 divided by 2 is 0. So there you go. Another example, propositional function. 2x plus 3 is greater than or equal to 5. There's a statement. By the way, it doesn't have a truth value yet. It gets a truth value when I supply a value from the domain of discourse. So what is, in this case, P of 0? P of 0 says 2 times 0 plus 3 is greater than or equal to 5. Is that true or false? Well, that's 3 is greater than or equal to 5. That's false. So P of 0 is false, but if I look at, let's say, P of 1, well, P of 1 would be 2 add 3, which is 5. Is 5 greater than or equal to 5? The answer is, sure is. So P of 1 is true. All right, another propositional function is this conditional statement. If x is greater than 3, then 2x plus 3 is greater than or equal to 5. The domain of discourse in this case is, I pick it to be the set of real numbers. All right, so let's think about that. Let's plug in some values. What's P of 0? P of 0 says if 0 is greater than 3, then 3 is greater than or equal to 5. Is that true or false? Let me write that down. If 0 is greater than 3, then 3 is greater than or equal to 5. And that statement is P of 0. Okay, is it true or false? Well, let's think. This is a conditional statement, right? Here is the hypothesis. Here is the conclusion. The hypothesis, 0 greater than 3, is that true or false? Well, the answer is false. And we should know that anytime a conditional statement has a false hypothesis, the conditional statement is true. So I'd like to remind you that in this case, P of 0 is true. And now I'm just going to let you think about that, and that's all I'll stop there.